Alright, so we're going to go ahead and do a little bit more on simplifying radical expressions. There's going to be 4 different things that you really need to know to complete the pages in class today. And those 4 things are adding and subtracting radicals, finding common denominators so that you can add or subtract them, multiplying by something called the conjugate, which we'll do in a little bit in the 3rd video. And then the 4th thing is foiling with radicals. Depending on the class you're in, you may or may not have already done that. So you can skip that video if you already know what to do to foil radicals. But I'll do a problem in that video regardless. So the first thing I want you to do is look at page 22. And I want you to think about just when we add variables together in just normal expressions. Take note that in order to add 2 different things together, they have to be like terms. And I want you to think of radicals very much like the same way that we add variables, okay? So in this situation, we have 4x and 5x. We have 4x's and we have 5x's. In total, we would add those together and get 9x, right? When we come over here, we have 10x plus 3y minus 2x. Again, the like terms in this case are 10x and a negative 2x. When you combine those together, you end up with 8x. Notice that 3y cannot be combined. They are different, okay? This seems like a big flashback, right? We already know how to do this stuff, but it's going to connect a lot with radicals. So let's go ahead and compare that now to what we would do with radicals. Okay, so if we take a look right here, in order for radicals to be like terms, they have to have the exact same radicand, okay? So the rad 5 and the rad 5, those are like terms, so we can combine these. So 4 root 5 and 5 root 5, we have 4 root 5s plus 5 more root 5s. In total, we have 9 root 5s. And that is actually it for this problem, okay? You would want to see to make sure that that root 5 is simplified radical form, so if there's any perfect square factors, but in this case, yeah, this is it, okay? So take a look at this next problem. Again, look for those like terms. Look for the radicands that are the same. So you can almost think of the root 7 as an x and the root 6 as a y. They cannot be combined, all right? So we have, right here, we have 3 root 7 minus 2 root 7. We end up with just 1 root 7, which we can get rid of the 1 in our next step. And then we have 2 root 6 and 4 root 6, in total 6 root 6. Okay, so I'm going to go ahead and get rid of this 1. And that's our final answer right here, okay? All right, let's go ahead and take a look at one more. All right, so not all the time are we going to have our radicals already simplified. So in this problem, we have radicals that clearly have some perfect square factors in them. So let's go ahead and simplify them. So the idea is you should simplify first and then combine anything that has a common radical. So here we go. I see that this is a 4. And we can take a 9 and a 3 out of here. The 9 is the perfect square. Okay, we're going to add that to 5, and then in 12, perfect square would be 4. So root 4 times root 3. Added 2. 8. And in 75, we have rad 25 times rad 3. Okay, so we can go ahead and go down a step further. Just keep simplifying the radicals. So 4 times this is just 3. And root 3 comes down. Plus, we're just keeping it black. 5 times this becomes 2 root 3, and eventually you guys are just going to skip the step of writing down what the square root is. So square root of 25 is 5. So again, let's finish it out. 4 times 3 is 12 root 3, plus 5 times 2 is 10 root 3. You can see we already have some common radicals. Here we have 40 root 3. Okay, we can go ahead and combine like terms because all 3 of these have a rad 3, all right? If one of them were not a rad 3, then we couldn't add that together. So this right here, we have 12 plus 10 plus 40, which ends up getting us, let's see, 62? 62 rad 3. Okay, so that's our final answer here. That should give you what you basically need for adding and subtracting radicals. Next step that we're going to do is we're going to do finding common denominator so that we can combine radicals. So that's it there.